Yeah, hi friends. On this day, in this video, we are going to study format specifiers in C. We are having integer, character, and float format specifiers. Let us see one after another character related. So everyone knows that you are going to have a format specifier percentage %C for a character. Let us see one example. So what we are going to do is we are going to print, say printf. I want to print a character that is written in single quotes, that is say sums x. I want to print x value. So here what is that? You're going to write is %C. Then keep a semicolon. Then let us execute this one. Execute, compile and run. Yeah, we got the result. We got x. Yeah. Now here we haven't declared any variable. We can declare a variable, say integer c is equal to sum y. I want to display y now. I want to display y. So what you're going to write? Semicolon. Then print a %C. Instead of printing a character constant, if you are writing x in single quotes, then it is called as character constant. So you're going to write here, instead of character constant, you're going to write c, because c is going to have the value y in it. C is going to have the value y in it. So let us execute this one. Execute F11. Now you got y, because c is having value y. Now another possibility is you can write printf and scanf. So what we are going to write? Printf, then enter a character, then scanf. Now inside the scanf also you are going to write the conversion code, that is %C, comma, you are accepting a character, so you're going to write a %C over there. Then ampersand, variable name is c, so you are going to write %C, semicolon. Now here, instead of printing, yeah, c, same thing. Let us execute F. Now it is asking for enter a character. Let us give a character called as b. So we got b. Now let us execute it again. Enter a character. I am giving now value 8. 8 is a number, but we are giving 8 as a character, so it is going to print as it is 8. Now on this 8 you cannot perform the operations like addition, subtraction, because 8 is going to get stored as a character. Now let us play with this character. Now I am taking integer c is equal to y. Have you noticed this one? You can take character as an integer data type also. What is going to happen here? If you write character, you are going to get the same output. Let us execute. So I'm giving value as b. I'm getting the result as b. Now what exactly is happening is, now instead of giving character c is equal to y, I am giving character c is equal to 65. I am giving an integer. Now 65 is the ASCII value of some character. It is going to get converted into that particular character here. Let us cross check. 65, character c is equal to 65. I am not going to take the value directly. I am going to stop this printf and scanf time being. Now c is equal to 65, whether it is going to print 65. Let us cross check. Now you are getting capital A. So 65 is the ASCII value of capital A. If we give 66, 66 is the ASCII value of character B. See the output, you got B. Now like this, every character will be having a ASCII value. Suppose you are giving a value A as a character, you are giving value A as a character, then what it is going to do, it is going to change it into a integer 65. Then this 65 will be converted into its equivalent binary, and that value will be stored in the memory location. So this 65 is called as American Standard Code of Information Interchange, ASCII. So this 65 will be stored in the form of a ASCII value inside the memory. Then this ASCII value will be converted into binary. Now if you use this 65, you can print A. If you use this A, you can print 65. Let us check that one. Now here I am writing 66. Let us change this one as A in single quotes, that is capital A, and instead of printing %C, let us make it as D. Now I'm having a character variable A and we are converting this into integer, but that's why we are using %D. Let us execute this one. Now you can see here B, you are getting B. Why? Because no, we are displaying as %D. Here is a problem. 65. Yeah, you are getting 65. That's the right answer. So %D means conversion into integer. If you give C, it is going to print the alphabet as it is. Let us execute as it is. Now another is, we are having another ASCII value which you need to recollect is 97. 97 is the ASCII value of small a. 65 is the ASCII value of capital A. Let us execute what we are getting. Small a. Okay, from here 26 characters. 97 plus 26 is the ASCII values of those small alphabets. 65 plus 26 is the sequence of ASCII values of capital A to capital Z. For this you can use loops for printing all the ASCII values. As of now we are not doing that because we didn't started loops yet. So let us get back to our slide. So character C, then is S. So no, S is used for conversion character. Format specifier S is used for printing a group of characters which is represented by a star there. Means it is a group of characters, means a string. Now let us display a string. Instead of using this character directly, let us print %S, %S, then let us display in double quotes hello there. Hello there is a group of characters. We are printing it using %S. Let us execute this one. So here you got as it is, hello there. Yeah, hello there, no issue. So we are going to use %S. The same, we in the scanf also you are going to do the same thing. For example, let us write here, but here you need to take an array character C of say maximum. Suppose we are taking 100 characters, you need to declare like this 100. You are going to accept 100 characters. So here you need to accept enter a string, not a character. You need to write enter a string. Then in scanf what you are going to write is %S, %S, then %C. No, for characters you don't write ampersand. Character array you don't write ampersand. Directly you are going to write the variable name. Then print, instead of printing hello there, we are going to print C because C is having the string. Let us execute this one. F11, enter a string. So I'm going to write this is a good video. What is that we have written? This is a good video. Let us print this. So the problem with scanf and %S is it will take only the first word with before encountering of a space. Now here you can see that we have written as this space is this, then space A space good space video. So scanf is not going to take spaces. It is going to omit the rest of the string. So that's why we got this. Let us re-execute this one. Enter a string. I'm going to write hello. It takes hello as it is. Now if you're going to write hello world, it will ignore the world part because in between hello and world we are having a space. Scanf will take up to space only. So this is the point which you need to recollect. Let's get back to the slide. So next one is %. percentage. Now this format specifier is going to print a percentage, because whenever you write a percentage in a printf, it will feel as if we are going to write a percentage d or percentage c or percentage s or whatever, which we are going to cover in this video now. So let us comment this one. Let us print, instead of printing entire string, I want to print a percentage symbol. For that, what you need to write is, you need to write 2 percentages. Then only you're going to get the percentage as the output. Otherwise it will feel that some character is going to come there, s or d or I and so on. Let us execute this one, F11. So you can see percentage symbol. You need to give 2 percentages to get 1 percentage symbol here. Let's get back to the slide. So the next one is integer related format specifiers. The first one is percentage d, as you know. Now let us cross check this one. So here directly, instead of writing character c, I am going to write integer, some variable called as x, integer x. Now you can write x is equal to 10 in the next line or in the same line you wish. So x is equal to 50. Then printf percentage d comma x. Now let us print this value of x. Let us write F11. So we got 50. No issue. Now instead of writing this x is equal to 50 directly, you can take printf and scanf. In the scanf also you are going to have the same percentage d. Suppose I want to print more than one value. Say I am having one more value called as y. Then I am assigning the y value as y is equal to 200. So I am going to write here percentage d x4 is equal to percentage d x comma y. What I want to print is, I want to print the x value, that is 50 into, so here in this percentage d the first value will be printed, that is x. X will be replaced there. So x is having 50, then I am writing into 4. You can write anything here, just I am writing as a simple example. So if you write x4 is equal to, it will be printing x4 is equal to directly, then a percentage d. This percentage d will be replaced with the value y. That is execute and check. So you got y. You're getting an error. Yeah, we didn't give semicolon here, so that's why we got error. Let's execute it. So we are getting 50 into 4 is equal to 200. 50 is value of x, 200 is value of y, where the value replaced. Instead of writing into 4, if you can write here, don't write 4 is equal to, write a, b, c, d, e, for example. Let us execute this one. So we got 50, a, b, c, d, e, 200. So that percentage is important, not what you are writing in the middle. So whatever you write in the middle will be displayed as it is. The first percentage d will be replaced with the first value argument, that is x, and the next percentage d will be replaced with the next argument, that is y in this line. So percentage d you are going to use in printf, scanf, and you can use n number of times. Let us see the next one. Next one is short int, that is the size of the integer is reduced here, short int. So you are going to use percentage hi. So instead of writing integer, you are going to write here short. So let us declare a variable called as x, not y, not required. So same program, let us modify. Instead of writing percentage d, you are going to write hi. Let us remove the rest of the line. So I want to print only x value. That's it. Let us execute this one. So you got short t. We lost t here, short. So you got 50. So what is the difference between integer and short? Let us give 500 and see the output. F10, F11, 500. Let us give 5000. Add one more 0. Yeah, we are getting the same output. But actually, it has to stop at 256 as per the theory. It has to stop at, because short is up to 256, 0 to 256. Okay, no issue. Let us move further. Let's see the next one. We are having unsigned short. There is a difference between signed short and unsigned short. If you don't write anything, it will mean as signed. For example, I want to print negative value minus 5000. Let us execute this one. You'll be getting exactly 5000 minus as the result. Let us make as unsigned short. Yeah, unsigned short HU. Let us write here unsigned short x is equal to minus 500. Then let us make it as HU. Let us execute this one. You can see some value which is having a lesser than 5000, means exactly the maximum value of our unsigned int is 65,536. So what it has done, the maximum 65,536 minus 5000 it is printing here. But what is our intention? We have to print minus 5000. So unsigned will not print the values which are having a negative value. They are going to get deducted from the maximum number. Say suppose I am having here, if I remove the minus, then I'll be getting exactly 5000 as the result. Get back to the slide. After this we are having long, where you can use percentage %L, percentage %LD or percentage %LI. Okay, as format specifiers. So instead of using a unsigned short, I'm going to use long x. So x is equal to some number. Then printf, instead of writing here, you can use L or LD. I'm going to use LD because some compilers L is not working. You can cross check in the compiler. So you got 55 lakhs, no issue. So here you are going to use percentage %LD as format specifier. Back to the slide. Next one, unsigned long, the same problem. If you are using a minus value, then you will be getting minus maximum value minus that one. Let us cross check. Let us give 1000 for better understanding. Give 1000, 100. Let us go with 1000. Let us give unsigned long. Unsigned long is equal to minus 1000, means maximum value minus 1000 will be printed. So the character is LU, not D here. Unsigned LU, long unsigned. Let us print it for unsigned long. F11. So you got the output 1000, correct value. If I give minus, then I'll be getting the maximum range minus 1000. So this is maximum range minus 1000 value. Back to the slide. Next one is long, where you can use LLI, means already integer is there, the double the size of the integer is long, and the double the size of long is long. So let us give the data type as long. So instead of using unsigned, we are going to write long. So LLI or LLD. So let us give LL long integer. So let us execute this one. F11. So we got the result as minus 1000, no issue because it is unsigned. I'm getting the value correctly. Then get back to slide. Next one is unsigned long, the same thing, but LLU is the character. Yeah. So you can also write unsigned long LLU. Let us execute this one. F11. So you got maximum number minus 1000. This is the maximum number. Let us remove the negative value, that is minus here. Execute it. So you will be getting the exact 1000. No issue. Get back to the slide. So next one is percentage %O. If you want to print a octal number, in octal number format, the octal number starts from 0 to 7. Let us get back to Excel. Now, for your understanding, I'm writing these numbers. So let us reduce the size a bit. Yeah, for your understanding, I'm writing these one. The starting number starts with 0, then a 1, then 2, 3, 4, 5, 6, 7, and there won't be any 8 in octal number. It will be 1 0 again. Then from there 1 1, 1 2, 1 3. Then so on at 1 7. After 1 7, you will not get to 18. You will be getting 20. 2 0. Then 2 1, and so on. I hope you understood this one. So what is this equal to? 1. This is 2. So the rest of the numbers. So 8 will be printed as, this is 0. Starting number is 0, 1. So yeah, this is decimal 8. Decimal 8 will be printed as octal 10. Decimal 10 will be printed as 12, and so on. Okay, let's cross check this one. Get back to the editor. So here what you're going to do is, instead of taking unsigned long, you can directly take integer, not require this many. Integer, say x is equal to, let us give as the value 8, because 8 means 10 is the output, and printf percentage o for octal number o. Let us execute F11. So we got that output as 10. So octal number 8 is 10. You can do experiments. And the next one is hexadecimal number. Get back to slide. So for next format specifier is hexadecimal, either small x or capital X. So hexadecimal means the same concept. Here hexadecimal will be having 1 to 15. So you will be having the same 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, in the hexa format, you will be having 0 to 9, then capital A, capital B, capital C, capital D, capital E. That's it. Then 10, it starts with 10. So 16 is equal to 10. Hexadecimal 16 is equal to 10. Let's cross check. So let us give x, same concept. Let us give 16 hexa. So here you will be having x as a character. Let us execute this one. So what is the output you got? 10. Now, for our understanding, let us give as 15. 15 means I need to get a. Can you guess? So we'll be getting an F. 0 to 9, A to F is the hexa format. So let us get back to the slide. Maybe integer are finished. Yeah, you can pause the video here. You can note down all this format specifiers. Next one is float. Float is starting with F. So if you are having, with this single precision value, let us get back to the screen. Instead of taking integer, you can use float. Float x is equal to 15. I am printing directly F. See, we don't have any decimal value for 15 over here. We don't have any decimal value, directly 15. So what will be the output? It must be 15, but you are going to get as 15.60. After decimal dot, you will be getting 6 zeros trailer. This is called a single precision. Suppose I am going to give 15.9. What is the output? 15.9 trailing zeros. After 9, you will be getting all zeros, rest of the 5. So totally you will be having 6. So some books will be having F also here. So let us see the output. If you are writing 15.9 F, also the same output, nothing difference. So some books represents that this is a floating point value. Now the problem comes when you try to convert this F into D. Means float you are printing as an integer. So what happens? 15 will be printed, 0.9 will be eliminated. See the output? Yeah, we got some minus value. So don't worry, this compiler is not printing as per the theory. What it has to do is it has to print here 15 only. If you see Turbo C compiler, there you will be getting 15. 0.9 will be ignored. Not an issue as of now. So let's get back to the slide. Double is LF. So here if you are using float, you need to use double. And the character is LF. Let's execute this one. So 15.9, same 5 zeros, total 6. But double is called as double precision. Double precision. Next one. So we'll be having float double. You can use G or C, but this is going to print in a scientific format where you are going to use E or G. Both are same. Let us take this one. Float double. We are increasing the size. Float double let us print this value 15. So float double x, float double x, is it LF? No, G. Float double x, yeah, F11, FLOAT WX. So this compiler is not accepting float double. Don't worry, maybe some other compiler is going to accept. Dev C++ is not accepting this one. Don't worry. Let us get back to the slide. Long double. Let us try with long double. It is going to accept long double. Capital LF is the character. Capital LF. Let us try to execute this one. Yeah, it's giving. So 0.00. It is taking x value as long double. I'm giving x as 15, but it is printing as 00. There is some error in this compiler, so here we are not getting 15.0000. So don't worry, maybe the problem is with the compiler. Next one, long double is over. Next one is scientific. Yeah, I want to print a value. Say I'm printing 15 value as 0.5, 15.5. If I'm going to use small e or capital E, it will be converted into a scientific expression and it is going to give the output in that format. Now see, let us see. So 3.2053000 minus E minus 317. So this F15 is the value, but it is printing in a scientific representation over there. So let's back to the slide. So that's it. So floating point, you can pause the video here, you can note down. So that's it guys in this video. Have a nice day.